Lesson 80 is yet another lesson on linear equations and linear functions, and this one is on horizontal and vertical lines. So we have a couple of rules about those here at the beginning. Let's just go over those. Horizontal lines, they have a slope that equals 0. So there's no change in y. I mean, just think about what a horizontal line is. Like here's an xy axis, or x f of x axis, if you want to call it that too. Remember, we use y and f of x interchangeably when we're talking about functions. And a horizontal line would be a flat line, like even with the horizon, right, or parallel to the horizon if you looked out at the horizon. And then a vertical line, it's just perpendicular to a horizontal line, right? It's parallel to the y-axis. But that's what they are. And so if you look at that, if you look at a horizontal line, the way it goes from left to right, just flat, there's no vertical change, right? There's no change in y, so delta y equals 0. And then if you think about the slope of a line, delta y over delta x, that's just going to be 0 over delta x, which is just 0. So the equation then, you think about y equals mx plus b, your standard form. If m is 0, there's no mx part, right? Because 0 times x is 0. It's just b. So that's the equation for a horizontal line. And b, what's that? That's the y-intercept, right? That's where it crosses the y-axis. It's just how the equation is for a horizontal line. Y equals the y-intercept. Vertical lines are super easy equation as well. And they have an undefined slope, we call it, because for a vertical line, it's just going straight up, right? There's never a change in x. It's just all change in y all the time over no change in x. So it's delta y over 0, and anything over 0, that's undefined. So that kind of makes the whole equation undefined, and so we don't use it. We don't use y equals mx plus b for vertical lines. We just say x equals c, where c is the x-intercept, that place where that vertical line crosses the x-axis. So you're familiar with y-intercepts. Well, there's an x-intercept as well, and hopefully that makes sense. If the y-intercept is a place where a line crosses the y-axis, well, x-intercept, that's just where it crosses the x-axis. So something to make a note of is that equations for horizontal and vertical lines, they equal the value where they cross the x or y axis. That's it. That's all they are. If you have a horizontal line, it's going to cross the y-axis, and so its equation is y equals wherever it crosses the y-axis. If you have a vertical line, it's going to cross the x-axis. It can't cross the y-axis because it's vertical. It's just straight up and down. And so its equation is where it crossed the x-axis. They're as simple as that. But again, we talked about horizontal and vertical, the meaning of those. You can go back to lesson 12 as well to think about that, and we'll practice that actually a little bit more as well. And keep in mind, horizontal and vertical lines, they are perpendicular. So that is a vertical line. It's perpendicular to a horizontal line. And the horizontal line is perpendicular to vertical lines. Up to now, the linear equations you've learned about have had both vertical and horizontal components. So they're oblique, like that one I'm drawing right now. That would be considered an oblique line, or slanted. And the lines we're going to consider here, they're not oblique. They're horizontal or vertical. Look at example 80.1. Like we said, we're going to practice a little bit more this idea of horizontal and vertical. And there's a bunch of lines there. Identify which ones are A, horizontal, and B, vertical. So let's take a look at this. So A, lines that are horizontal, even with the horizon, parallel to the horizon. They're flat. They extend from left to right and have no up or down component to them at all. So there's two of them there. Do you see them? This one and this one. And so we want to identify them by their outermost points, like this one, point A, and point E. And so we'll say line, there's actually two of them, so we'll say lines AE, Now remember, we could have called that EA. I'm just going from left to right here. EA is the same line. And then the other one is LJ. So those are our two lines, AE and LJ. So those are the horizontal lines in this diagram, and then B, we need to find the vertical lines. And just look at that. Which one or ones are straight up and down? So just this one right here, right? That's the only one that's straight up and down. And so that is B, and then the other end point there, K, line BK. Of course, you could call it like this. You could call it BK and then put a bar on the top with arrow tips on the end. You could describe it that way as well. But that's the vertical line there. Moving on to example 2, write the equation of each line shown there. And so look at A. You have a horizontal line. Remember, we just said that's where it crosses the y-axis. That's the equation. So here's the origin. Count up 1, 2, 3, 4. It's just going to be y equals 4. That's the equation. That's it. Look at B. Clearly, it's a vertical line. And where does that cross? Well, here's the origin, and to the right, 1. And that's it. We're not trying to do complex decimal number lines and things like that for the equation. It's just 1. X equals 1. That's it. That's the equation for that vertical line you see there. Let's do one more problem. On this one, which of the following is the equation of the line x equals minus 2? Okay, so it's x. That means it crosses the x-axis, right? So that means it's a vertical line. So A and D, those are oblique. C is horizontal. So it has to be B, but we can just double check that. It should cross through at minus 1, minus 2, and it does. And so choice B is correct there. And that is all for lesson 80.